Good morning, class. This is final exam review covering modules 1 to 4. Here's part 2, trigonometric functions, identities, equations, applications, periodic functions, polar coordinates, and vectors. Two boats that are leaving the harbor in different directions make an angle of 135 degrees. One boat has traveled 300 feet, and the second has traveled 350 feet. How far are these boats apart? Draw a diagram. Generally speaking, in cases like this, we have to draw a diagram, and I'm reminding you of the sine law as well as the cosine law. Sine law is sine A over A equals sine B over B equals sine C over C. Cosine law, A squared equals B squared plus C squared minus 2BC cosine A. And you can solve for cosine A and it becomes B squared plus C squared minus A squared over 2BC. So here's the drawing. So these are the two boats. They make a 135-degree angle here. And one has traveled 300, but one has traveled 350 feet. And of course, this is the distance BC or A is of interest to us. So in essence, we are dealing with SAS, side, angle, side. We use the cosine law. A squared is B squared plus C squared minus 2BC cosine A. So all we have to do, plug in all the values. So 300 squared plus 350 squared minus 2 times 300 times 350 times cosine of 135. The cosine of 135, the reference arc is 45 degrees, the same as cosine of 45 degrees. In the second quadrant, it's negative, okay, minus square root of 2 over 2. At this point, you have to use a calculator, plug it in, and figure out the answer. So A squared is given. You take a root, and A, the distance between the two, is about 600.83 feet. So it's pretty straightforward, everybody. Anybody want to read the question for us?
Yeah, I'll do it.
Please.
A rocket takes off at a bearing of N30E after flying for 900 meters. The pilot turns 90 degrees and heads towards northwest. After flying for 1,000 meters, what is the new bearing of the plane? Draw a diagram.
Excellent. So reminding everybody of the bearing, basically we either make north or south first and the closest angle to it. For example, this one is north, 30 degrees east. This one is north, 70 degrees west, and so on and so forth. So for example, this one, which we don't have the answer, is south, 20 degrees east. Just as an example to remind everybody of that. So north, 30 degrees east. This may not be too scaled, but that gives you an idea. So we are going this way. Turning 90 degrees, and that's going 900 meters. Then turning 90 degrees. When you turn 90 degrees, you can go this way or that way, but northwest, because you could even go this way, okay? This is a 90-degree angle. and we fly about 1,000 meters. So this is now 1,000 meters. We are interested in finding the new bearing. So what is the new bearing? The new bearing is north, whatever this angle is, alpha west. That's what it is. So we can find this angle theta we know this is 30 degrees. So theta minus 30 degrees is of interest to us. Alpha is theta minus 30 degrees. So in this triangle, tan of theta is the opposite, 1,000 meters, over the adjacent, 900 meters. And theta is tan inverse of this, or 10 over 9. And it gives us 48 degrees or so, roughly 48.01. So that's theta. What is alpha? Subtract 30 degrees. And that's the final answer. North, 18.01 degrees west. Plot the points first, then find their coordinates. Find the rectangular coordinates for 6, 150. Well, first we go 150 degrees, and then 6 tick marks. That is how we locate that. Reminding everybody, as far as polar with representation of r comma theta, rectangular with the representation x comma y. X is r cosine theta, y is r sine theta. The case of a rectangular is unique, but polar is not. R comma theta is r also r comma theta plus 2k pi, or minus r theta plus pi plus 2k pi. This means odd multiples of pi, where k is an integer. And so x equals r cosine theta. So 6 times 5 pi over 6, as you know. 5 pi over 6 and 150. On purpose, I want to go back and forth. I want to remind you 150 degrees is the same as 5 pi over 6. And as you know, it's the same as pi over 6 in the second quadrant makes it negative. So cosine of pi over 6 is square root of 3 over 2. But in the second quadrant is negative, negative square root of 3 over 2. And that gives us negative 3 square root of 3. Y is our sine theta. Sine of pi over 6 is 1/2. In the second quadrant, 5 pi over 6. Sine is still positive, so 6 times positive 1/2, giving us 3. Therefore, 6 comma 150 is the same as minus 3 square root of 3 comma 3. Find the polar coordinates for this pair. You have to find the r. X squared plus y squared equals r squared. So first location, you go 2 to the right, 2 down. 2 to the right, 2 down, because it's negative. And rectangular to polar, x squared plus y squared equals r squared. Tan theta equals y over x. And you have to adjust for the quadrants. So x squared plus y squared. That means 2 squared and negative 2 squared. This is 4. This is 4. It's 8. And the square root of 8 is 2 square root of 2. By now, everybody knows that, but let me just quickly write that. So square root of 8 is square root of 4 times 2, and that's what we get. Tan theta is y over x is negative 2 over 2, and it makes a negative 1. Theta is minus pi over 4. And if we want it positive, we just, so minus pi over 4, or add 2 pi to minus pi over 4, becomes 7 pi over 4. It's the same thing. Makes no difference, everybody. transform the polar equation r equals 2 cosine theta to an equation in rectangular coordinates and graph. So reminding everybody that x is r cosine theta, r squared is x squared plus y squared, r equals 2 cosine theta given. So the technique is to multiply both, resulting in r squared equals 2r cosine theta. Replace the r squared with x squared plus y squared, and 2 times r cosine theta will be replaced with x to x. We bring everything to the same side because we remember the basic circle x. So we have x squared plus y squared equals r squared, x minus h quantity squared plus y minus k quantity squared equals r squared. So we could put these two together. And this is the value of b. You remember that? Negative 2 divided by 2 is negative 1 and squared is positive 1. Okay, so b divided by 2 is negative 1 and squared is positive 1. So you're looking at x minus 1 quantity squared plus y squared equals 1. So we are looking at a circle centered at 1, 0 with the radius of square root of 1 over 1. So here's roughly 1, 0, and here's the identify, graph the equation, and convert to a rectangular equation. So when r is given, basically, you square that, and you get r equals 16, and you notice that a circle x squared plus y squared equals 16. This is an easier representation in polar than in rectangular coordinates. So it's a circle centered at 0, 0 with the radius 4. So that's what it is. Theta equals 3 pi over 4. When theta is a constant, we take a tangent of both sides. And because we know tangent is y over x, okay? So tan of theta is tan of 3 pi over 4. And the tan of 3 pi over 4, we know it to be negative 1. We also know it to be y over x. So that means y is minus x. And that means it's a line through the origin going this way. So reminding you of the theorem, r equals a is a circle which has a center at the pole with the radius a. Theta equals a constant alpha is a line y equals tan of alpha times x. R sine theta is a constant that's a horizontal line y equals a. Or cosine theta equals a constant that's a vertical line x equals a. Or equals plus minus 2a cosine theta, or equals plus minus 2a sine theta. All of them are circles in the case of a cosine, and all of them have the radius a. When cosine is involved, the center is located along the x-axis or the polar axis. In the case of a sine, along the y-axis, or the line theta equals pi over 2. So as an example, if we want to graph r equals 1 minus cosine theta, we can And I remind you that r equals a times 1 plus minus cosine theta. It's a cardioid looking like a heart shape, and it passes through the pole. So we basically plug in. So for theta, we pick easy numbers. For example, if I pick 0, 0 cosine is 1, so 1 minus 1 becomes 0. Pi over 6, 1 minus cosine of pi over 6, 1 minus square root of 3 over 2. Pi over 4, 1 minus cosine of pi over 4, 1 minus square root of 2 over 2. Pi over 3, 1 minus 1 half, 1 minus cosine of pi over 3, 1 half, which gives me 1 half. Pi over 2 cosine is 0, so that's 1. 2 pi over 3 is the same as pi over 3, but negative, so 1 minus negative 1 half, which makes it 1 plus 1 half and makes it 3 halves. Pi makes it negative 1 minus negative 1 gives me 2. And those are the pairs. So you plot 0, 0. Let's plot easy ones. This you have to put it into a calculator. For example, the square root of 3 is 1.71 divided by 2 and then subtract it from 1 and so forth. So let's go with 1 half and pi over 3. So you find pi over 3 and you go, see, about 1 tick mark, we're going to assume it to be about half, 2, 1. Okay, 3 halves, 4, 2, roughly. And so 1 half and pi over 3. So 1 and pi over 2. So pi over 2 is here. And you go 1 tick marks, which in this case we decided to go with 2, okay? It's half and half. So 2 and pi. So pi is in along this line. And we said this is half, 1, 1.5, 2. So somewhere here. Okay. 3 halves, 2 pi over 3 also is this one, by the way. This is 2 pi over 3. And so looking like this, looking, if I were to graph it, looks like that. Okay. Now, if I replace the theta with negative theta, I get the same answer, which means it's symmetric with respect to the x-axis, or better yet, polar axis. Okay. Symmetry with respect to the polar axis, r comma theta can be replaced by r comma negative theta, resulting in an equivalent equation. The graph is symmetric with respect to the polar axis. So you go like that. Just flip it over with respect to the x-axis or polar axis. That's all you have to do. Or you can pick up numbers, for example, 4 pi over 3. 4 pi over 3 cosine is negative 1 half. 1 minus negative 1 half makes it 3 pi, 3 halves. 3 pi over 2 makes it 0. 1 minus 0 is 1. 5 pi over 3 makes it, remember, in the fourth quadrant, it's the same as pi over 3, and it's positive 1 minus positive 1 half makes it 1 half, and 2 pi gives you positive 1. 1 minus 1 is 0. And so you can graph them like those, or like I said, just the fact that they are symmetric. It makes it just as easy. Plot the complex number 1 plus I in the complex plane and write it in polar form. So let's remind everybody z equals x plus yi, or r cis theta, or r cosine theta plus I sine theta. R squared is x squared plus y squared. The modulus, or the magnitude, of z equals r equals square root of x squared plus y squared. The tan theta is y over x. And so here's the real axis, in essence the x-axis. Here's the imaginary axis, in essence the y-axis. And z is x plus I y, and z bar or z conjugate is x minus iy. So this is reminding you of some of this information, including I being square root of -1, for example, right? Or I squared is -1, I cubed is I to the power of 4 is +1. So just to remind you. And so we need to find R, which is square root of x squared plus y squared. As far as the plotting is concerned, so one along the x-axis or the real axis, one along the y-axis or the imaginary axis, that gives us this location. Okay. And now we are going to calculate the R. And this is 1 plus 1i. Remember that 1 plus 1i. So 1 squared plus 1 squared. So makes it square root of 2. Tan theta is y over x. And that gives us theta of 45 degrees or pi over 4. So according to this one, you can go with this, or this is a shorthand notation. And replace the R as well as theta. So square root of cosine 45 plus I sine 45, or you may write it as square root of 2 cis 45. That's the same thing. It's a shorthand notation, everybody. We want to write this complex number in rectangular form, which means basically you just multiply by replacing cosine of 7 pi over 4. So this 7 pi over 4, as you know, is in the fourth quadrant. So it's the same as pi over 4. Cosine of pi over 4 is square root of 2 over 2. Sine of 7 pi over 4 is negative because in the fourth quadrant, sine is negative. So this is square root of 2 over 2, but this is negative square root of 2 over 2. Multiply by 4. Here's your final answer. Okay. Here's the point. All right, we are going to multiply z by w and divide z by w, where z and w are given, and reminding everybody of the formula. Z1 times Z2 is R1, R2, cis theta 1 plus theta 2. Z1 over Z2 is R1 over R2, cis theta 1 minus theta 2. So we want ZW. So let's multiply these two. So according to this formula, we're going to multiply 2 and 2. And then cosine of pi over 8 plus pi over 10 plus I sine of pi over 8 plus pi over 10. 40 is the common denominator, so we get 5 pi plus 4 pi, and we are done. Of course, 2 times 2 is 4. For the division, we write them again. First, these two numbers cancel each other. And then we get cosine of power 8 minus power 10 plus I sine of power 8 minus power 10. And again, 40 is the common denominator. This time 5 pi minus 4 pi gives us pi over 40. So basically reminding you of what we have been doing. Everybody write this in standard form. So I remind you of De Moivre's theorem that says when z is given as r cosine theta plus I sine theta, you want to raise it to the power of n. You raise r to the power of n, and then you multiply the argument of sine and cosine by n. Therefore, if I want z to the power of 6, I'm going to raise this to the power of 6, and I'm going to multiply this one by 6. So this one to the power of 6, and this one times 6. So what happens is, obviously, this is 3 cubed, but this one goes away. So square root of 3 to the power of 6 is 3 cubed, or 27. Now, 5 pi over 3, the reference arc, again, I'm going to remind you by writing it. The reference arc is pi over 3, okay? Reference arc. In the, so it's the same as cosine of pi over 3, which is 1/2, because in the fourth quadrant, cosine is positive. This is the same as sine of pi over 3, but negative, because sine is negative in the fourth quadrant, minus square root of 3 over 2. So that's what we have, and we can distribute. Now we want to find the roots, cube roots. So we have the product, the quotient, the power, and now we have the roots. If a number is represented by r cis theta sub 0, then the nth root is the nth root of r cis theta sub 0 divided by n plus 2k pi divided by n, and we go from k equals 0 all the way to n minus 1. And if you have a real number that such as z equals 8, where the imaginary part is 0, okay, 8, 10, 2, any number that the imaginary part is 0, it's r cis 0, and r is 8. So 8 is 8 cis 0. If it's 10, is 10 cis 0. I'll just make something up. For example, if the number is 20, everybody, then it's 20 cis 0. Okay. All right. And so we're going to go with that. And so we want the cube root. So n is 3. So n is 3, everybody. And theta sub 0 happen to be 0. Now, cube root of 8, everybody knows it to be 2. This goes away. So 2k pi divided by 3. And k can be 0, 1, 2, all the way to n minus 1. N is 3. Cube means n is 3. So all the way to 2. So 2 cis 0. 2 cis 2 pi over 3, and 2 cis 4 pi over 3. Just replace the k with 0, 1, 2. Those are the answers. So if you plug in 0, 2 cis 0, cosine of 0 is 1. Sine is 0, simply 2. And you know cube root of 8 is 2. But cube root of 8 If you set x cubed equals 8, it has three complex solutions. These are the other two solutions now. Z1 is 2 cis 2 pi over 3. Now, 2 pi over 3 is the same as pi over 3 as far as the reference arc is concerned. Cosine is negative in the second quadrant, but sine is positive. You multiply it by 2, you get -1 plus I squared of 3. For the last one, cosine of 4 pi over 3, again, in the third quadrant, it's negative, and so is sine. In the third quadrant, so is sine, minus. Both of them are negative. So those are the other two, okay? So, again, a number has 3 cube roots. Number 2, we knew that, and now we came up with the last. Vector V has initial point P and terminal point Q. Write it in the form AI plus BJ. Find its position vector. Also find its magnitude. P is given as 3, 2. Q is given as 5, 6. So let's remind everybody of a few things. So we have a vector with the initial and terminal points. X of 2 minus x of 1 is this distance, and y sub 2 minus y sub 1 is this distance. And now if you have it such that the initial point is at the origin, it's called the position vector. So if V is the vector AB is an algebraic vector whose initial point is at the origin, and that's the key, then V is called the position vector. Algebraic vectors are represented as AI plus BJ, or vector brackets A comma B. A and B are called components of the vector. A vector with initial and terminal points x sub 1 sub y sub 1 as the initial, q sub x sub 2 and y sub 2 as the terminal is equal to the following position vector. So with that being the case, x sub 2 minus x sub 1, 5 minus 3, and y sub 2 minus 1, 6 minus 2. And that simply gives us 2 and 4, or you can write it as 2I plus 4j. Either way is fine. Depends on how they ask you. Magnitude, or the modulus squared of a squared plus b squared. Magnitude is always non-negative. If the magnitude is 0, so is the vector. And the magnitude of two vectors that are opposite is the same. And if you multiply it by a scalar, you can take the scalar out as an absolute value. So if this is the case, plug in A and plug in B. That means 2 squared plus 4 squared. 4 and 16 is 20. Square root of 20, that means square root of 4, which is 2 square root of 5. Given V as negative 2i plus 3j and W as 5i plus minus 4j, we want to find the magnitude of V plus W, and 2V minus 3W. Again, reminding you of the information from the previous page, also how we do the adding. So this is the U vector, this is the V vector. If you put the initial point of V at the terminal point of U, you get U plus V. And then you can add W. This is the resultant vector. All right. So the magnitude has this formula. So for V, we're going to put -2 squared and then 3 squared, 4 and 9 square root of 30. We want to add these two. We're going to add -2 and 5, 3i, 3j, and minus 4j minus j. 2v minus 3w, so just 2 times this vector minus 3 times this vector. So let's distribute. You get minus 4i plus 6j minus 15i plus 12j, and these two give us negative 19i. These two give us 18j. Find the magnitude, direction, angle, and a unit vector in the same direction for the vector v equals 3i plus 3j. So we have this information from before. Now the magnitude is the square root of a squared plus b squared. That's the first thing we want to find. So this is 9, this is 9, 18, and 18 is 3 square root of 2 because this is 9 times 2, 9 comes out. Now let's add more information. So V is the magnitude times cosine alpha I plus sine alpha j. Direction angle alpha is between 0 and 360, which makes it between the vector and the I vector, the x-axis in essence. So V is 3i plus 3j. So we have to find the tangent, which is b over a, and b is 3, a is 3. And because it's in the first quadrant, we get 45 degrees of power 4. So that's the magnitude, that's the direction angle. And we write it in this fashion. The magnitude, 3 square root of 2, cosine of 45 degrees I plus sine 45 degrees j. And we want to add the unit vector. What is a unit vector? Unit vector in the direction of v is v divided by the magnitude of v. And v has components ab, a times 1 comma 0, and b times 0 comma 1, a or bj. So this is the I, and this is the j vector. So it has this formula. All we have to do, write the vector v at top, and its magnitude 3 square root of 2 at the bottom. When we do that, you get 1 over square root of 2. And I hope you remember 1 over square root of 2 is the same as square root of 2 over 2. Just to remind you, 1 over square root of 2, if you multiply by square root of 2 over square root of 2, you get square root of 2 halves, okay? So All right. Could somebody read this question, please?
A plane is flying at a speed of 200 miles per hour on a bearing of n 55 degree E. The wind is blowing from west to east at 35 miles per hour. Approximate the ground speed of a plane to the nearest miles per hour and the true course of the plane to the nearest tenth of a degree.
Excellent. Thanks. Again, reminding everybody of some information. So let's see what's happening here. So it's flying north, 55 degrees east at a speed of 200 miles per hour. So if this is 55 degrees, this must be 90 minus that, 35 degrees. And so the magnitude of the velocity relative to air is 200 miles per hour. And remember, the angle is the angle that makes with the x-axis or the y-axis, if you will. So 35 degrees. The wind is blowing from west to east, west to east, this way. If so, the magnitude is 35 miles per hour, and the angle it makes is parallel to the x-axis, if you will. The angle it makes is 0 degrees. 0 degrees. And here's the true course. With this angle, so the ground speed is the magnitude we have to calculate, and the true course or direction is north, east, this angle. What is this angle? 90 minus theta. So we need to find the magnitude, and we need to find this angle. In order to find this angle, all we have to do find theta and subtract it from 90. So let's get to work. VA, according to this formula, is 200 cosine of 35 degrees I plus sine of 35 degrees J. You use a calculator to find cosine 35, sine 35, and you multiply by 200, and you put it in this format using its components. We do exactly the same thing with the wind. And of course, we know cosine of 0 is 1. But sine is 0, so simply 35i. And so the resultant vector is the sum of these two. So we add these two, and we can add these two components. This one doesn't have any component, just so add them up. So we add these two numbers, and we get 198.83i. This one is itself. So what is the magnitude? The velocity is square root of a squared plus b squared. So square this one, add them up and take a root. So that's the speed, about 230 miles per hour. Tan is b over a. So for this one, this angle becomes b over a, which means this is b, this is a. And using a calculator, we end up about 30 degrees. So 90 minus that makes it 60 degrees. So the answer is 230 miles per hour north, 60 degrees east.